Hey guys, welcome to Pre-Calc lesson 6.2 on ellipses. Before we get into ellipses, let's talk about a different factor by grouping technique. If you notice here, we try and group these two binomials. I could take out a GCF there of an x. That would leave me with an x plus 8, but there is no GCF there, so that's not going to work. So what we want to do is maybe group a trinomial and leave that for now. If you notice this trinomial, signs are the same, both positive, two numbers that multiply to 16 add to 8, that's going to be x plus 4 times x plus 4, which is great, but I'm going to write that as x plus 4 squared minus 25y squared. Now, I know it looks a little bit more complicated than what you're used to seeing, but this is the same thing as a squared minus b squared, which factors to a plus b, a minus b. All right, a is just x plus 4, and b is just going to be 5y. So to factor this, I can do x plus 4, let me put that in parentheses, make it a little bit easier to visualize, plus 5y times x plus 4 minus 5y. And now that is fully factored. I have this factor times that factor. Now these parentheses here and here are not necessary, but you can certainly put them in. Okay, one more like that. Once again, factoring by grouping with a binomial and a binomial won't do you much good. So I'm going to factor this trinomial here. That's going to be a plus 5b squared minus 100. So now the difference of two perfect squares. I'm going to take the square root of this. So that's just going to be a plus 5b. Let me get my pen. A plus 5b, a plus 5b. One sign is plus, one is minus, and I take the square root of that. It's just going to be 10. And that is factored. And we'll practice more of these throughout the unit. Okay, let's get into ellipses. So we talked about on day one how you form the conic section of an ellipse. That's if you take your cutting plane here and you move it off of parallel from the base. So this would give you a circle, and then you take that plane and you start tipping it up. Now that gives you an ellipse. Well, how do you define an ellipse in a two-dimensional space? Well, here's how you do it. The definition of an ellipse is the set of all points such that the sum of the distances from two fixed points, which we call foci, is constant. So in our diagram here, that's saying this distance plus this distance equals some constant number. So if I make this a 10 and I make that a 5, that distance is 15. Well, I could do this, and maybe that's 7 and that's 8. Oh, that still adds to 15. Maybe I could do this, that's 3 and that's 12. Well, that still adds to 15. So you just keep doing that over and over and over again, and all of these points will form an ellipse. So if you wanted to write like a geometric statement, you could say the segment F1P plus the segment F2P equals a constant. All right, what's the standard form look like? Standard form equation, it's going to look a little bit familiar to you guys. X minus h squared over a squared plus y minus k squared over b squared equals 1. Well, this part looks just like a circle. And we're going to get the same information from this part of the equation as we would in a circle. That's going to give us our center. So over here on the side, let's talk about the different parts. The center of the ellipse is going to be hk. Now, what are these things? Well, A is simply what we call the major radius. B is the minor radius. So what does that mean, major and minor? Well, in a circle, the radius is constant. In an ellipse, it changes. So we're going to talk about a major radius and a minor radius. Now here's where it gets a little confusing. A is not always under the x. That could be the B. The minor radius could be on the x-axis or horizontal. But what this always represents is what we call the x pull squared. And that's how far you go from the center to the end of that axis. And this is what we call the y pull squared. Now there's one other distance we need to talk about, and that's going to be the distance from the center of the ellipse to a focus. And that's going to be called c. So lowercase c is going to be what we call the focal radius, or basically the distance from the center to the focus. All right, well, this might make a little bit more sense if we can put them in diagrams. So here we go. We have two ellipses. And the one on the left, I'm going to identify certain points. That's obviously going to be my center. The endpoints of the major axis, which is the longer one, contain the vertices. So that is a vertex, and that is a vertex. The longest axis, so in this case it's horizontal, is the major axis. So in this case, it's that one. The shorter of the two, so that's this one here, is the minor axis. Now, up here we talked about x pull and y pull. The x pull is not always the longest. Here's what those represent. The distance from the center to the end point of the horizontal axis, if you will, that is known as the x pull. That's how far you go from the center to the end point of that axis. And then from the center to the end point of this axis here, that's known as the y pull. So that's how you go about graphing these ellipses. So now we also have to talk about the foci. In the diagram on the right, let's label the two foci. We'll call that F1, focus 1, and F2, focus 2. So borrowing from our diagram on the left, this distance here, I'm going to call B. Why? That's the minor radius. This is the shortest axis, so that's the minor axis, and that's the minor radius, which goes from the center to this endpoint. Well, here I told you that C, lowercase c, not to be confused with the center, is the focus radius, or focal radius. So that distance from the center to a focus is lowercase c. Now here's what's pretty cool. All right, it's kind of a hard visual here, but I'll show you some websites in a second. You can check out the visual. This distance is A, right, the major radius. It turns out if you take this and then you start sliding this point up, I think you can visualize this point's going to come in here. So as this segment does something like this, it turns out the distance from the endpoint of the minor axis to the focus is the same thing as A. So this distance right here is the same as that distance right there. All right, so let's draw that in and label that A. So now I have a right triangle, and there's a super important relationship here. And this is where it gets a little bit confusing because you guys are so conditioned with the Pythagorean theorem, c squared equals a squared plus b squared. But if you look at this triangle, all right, B and C are the legs. So using the Pythagorean theorem, a squared equals b squared plus c squared. Now that doesn't do me a lot of good because usually what I need to do is I need to find c. I need to calculate this. A and b I'm going to get from the equation, but I always have to calculate c. So I want this equation solved for c. C squared equals a squared minus b squared. I know it's going to be confusing because you're like, well, wait a minute, that's not the Pythagorean theorem. It actually is. We just switched where the a and the c were. Okay. So c squared equals a squared minus b squared. That's how we calculate this distance from the center to the focus, and that's how we find the coordinates of the foci from the standard form equation. Okay, so before I move on, let's talk about general form. How do you know when you're given general form if it's an ellipse versus a circle or hyperbola or parabola? So general form is going to look like this. Ax squared plus by squared plus cx plus dy plus e equals 0. So how do you know it's an ellipse, not a circle? A does not equal b. So these two values here and here will be different. This could be like a 4, that could be a 9. This could be 12, and this could be 6. They're not equal. If these are the same, then it's a circle. Not equal, that's an ellipse, because it gets pulled in one direction more so than the other. Okay. Before I move on to a few examples, if you're in class, we're going to check this out. It's kind of a neat visual on ellipses. But if you're at home, sorry that's not an active link, but maybe you could type that in and it gives you a good visual and shows you the differences between A and B and how to calculate C. But anyway, back to this example. We're going to start with an easy one. If you notice here, the center is going to be 0, 0. And this right here is going to give me my x pole. I'm going to write it out slowly here. The x pole is the square root of that number. So the x pole in this example is going to be 3. The y pole is the square root of that number, so that's going to be 5. I know my center is 0, 0. That's all you need. You can sketch the ellipse with that information. Here's how we're going to do it. And you're going to notice we're going to be hand sketching a bunch of these. So the center is 0, 0. X pull tells you how far you're pulling in the x direction. So if the x pull is 3, that's 3, and that's 3, and those would be those endpoints. All right, well, that's not too bad. 1, 2, 3, there's an endpoint. 1, 2, 3, there's an endpoint. My y pull is 5, so that means I'm pulling in the y direction 5 to get to those endpoints. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Endpoint here, endpoint here. So now I need to sketch this in. And when you sketch in an ellipse, do not think football. Think more like rugby ball or a watermelon. It's kind of rounded at the end. And they're hard to draw at first, but you'll kind of get the idea. Kind of rounded at the ends, and then here almost goes straight through. All right, so just do, don't rush it. Just do the best you can. We're going to talk about a few things tomorrow that will help you make a more detailed sketch. All right, so now what do we have to identify? Well, I identified the center. I need to identify my vertices. My vertices are the endpoints of the major axis. This is your major axis, right? That's the longer one. So that's a vertex. We'll call it V1. And that's a vertex. Let's call it V2. So coordinates of V1 and V2. I'm just going to count. That's going to be 0, 5 for V1 and 0, negative 5 for V2. So there's two other points you need to identify. Now, the foci. How do you get that? Remember the equation. C squared equals A squared minus B squared. Now, one thing that's kind of nice about this is that this has to be positive, right? The distance from the center to the focus has to be positive. So you're like, well, I don't know which one's A, which one's B. A is always the bigger one. This is A squared, and that's B squared. So I'm going to take 25 minus 9. One thing I also want you to start getting used to doing is in the beginning here, identifying which one is A and which one's B. So this is actually the A, because it's bigger, and that is B. So in this particular standard form equation, it'd actually be x squared over b squared plus y squared over a squared. A is just the bigger of the two. But what's under the x is always the x pull. What's under the y is always the y pole. All right, so back to c. C squared equals 25 minus 9. That's going to be 16. Square root it. C equals 4. Well, what is 4 again? That's the distance from the center to the focus. So here's my center. 1, 2, 3, 4. That would be F1. 1, 2, 3, 4. That would be F2. What I want you to notice here is that the foci and the vertices are always on the major axis. All right, so you always go from the center towards the vertex, and that's where the focus is going to be on this side. The foci are always inside the ellipse. So now I need those coordinates. Let's see, F1 is going to be 0, 4, and F2 is going to be 0, -4. All right, so I found the center, I found the vertices, I found the foci, and I made a sketch. All right, let's tackle one that's a little bit more challenging. All right, so I gave you the last one in standard form. This one I'm going to give you in general form, and this is where it gets very challenging. So like a circle, I need to do completing the square. So I'm going to group my x's, I'll group my y's, I'll get this number to the other side, I'll subtract 1. All right, so I've got 4x squared minus 16x plus y squared plus 2y equals -1. Now here's where it gets challenging. This is not a problem at all. Oh yeah, I can complete the square on this. That coefficient is 1. I'm just going to take half of this and square it, so I'm just going to be adding 1 here and adding 1 there. Where it gets difficult is over here. I can't complete the square with a 4. But what we're going to do now is I'm going to take out a GCF. We will only give you equations where you'll be able to take out a GCF in both of these. All right, it'll be extremely messy if this was not divisible by 4. And again, what's going to be important is that you organize your work and don't rush. Okay, so now let's take half of this and square it. Okay, so what's that going to be? Half of 4 is 2, squared is 4. Here's where it gets complicated. I am not adding 4 here. Why not? Because I'm not really adding 4 here. Here's where it gets tricky. I'm really adding 16 because I took out this GCF. 4 times 4, I'm adding 16. So I need to add 16 on here. Again, that's another area where we see mistakes, but this one's a little bit challenging, so it's certainly understandable. So I add 16. Over here with the y's, add 1, add 1. Okay, so now what happens? Here I have 4 times x minus 2 squared plus y plus 1 squared equals 16, right? -1 plus 16 plus 1 is 16. Now, if you think back to the standard form of an ellipse, I need a 1 over here. So what we do next is we divide by whatever number this is to make it a 1. Divide by 16, divide by 16. So let's see what that looks like. So with my x's, obviously 4 goes into 16 4 times. So now this is going to give me x minus 2 squared over 4 plus y plus 1 squared over 16 equals 1. And there is your standard form. So from this, first two things I'm going to get right away, I'm running out of room, apologize. My center is going to be 2, -1. My x pull is going to be 2 because it's the square root of whatever's under that. And it's the smaller one. The smaller one is always b. My y pull equals 4. Again, where does that come from? It comes from the square root of what's under the y. And that's going to be your value for a because it's bigger. Now, before I get the foci, I usually like to take that information and make my sketch. All right, so my center is 2, -1. 1, 2, -1. There's my center. X pull is 2, so that means I need to go 2 that way and 2 that way. Okay, 1, 2, there's the endpoint. 1, 2, there's an endpoint. this right here is going to be your minor axis. All right, let's get the major. The y pole is 4. Let's go down 4. 1, 2, 3, 4 from your center, and then up 4. 1, 2, 3, 4. So that's going to be the major axis. Your ellipse is going to kind of look like this. So again, let's take our time, sketch that in. More like a watermelon than a football. Okay. Since this is the major axis, my vertices are going to be here and here. Let's label those. V1, V2. Write those coordinates down. V1 is 2, 3. V2 is 2. What's that? Negative 1, 2, 3, 4, 2, negative 5. Always identify the vertices. Next, I need to get the foci. So I remember c squared equals a squared minus b squared. C squared equals 16 minus 4. That's going to be 12. So c is square root 12. They're always going to want these in radical form. So that's going to be 2 radical 3. And for graphing purposes, let's estimate square root 12. That's going to be 3 point something. Right? I'm just going to call it 3.5. So to put these in the graph, I know I need to go down 3.5 from the center and up 3.5 approximately. So that's going to put me right about here. There's F1 and 1, 2, 3 right about there for F2. So now here's the tricky part. It's going to want these in simplest radical form. So I need to use this distance. I know this distance here is 2 radical 3. Well, how do I get that coordinate? That is 2, negative 1. What are we doing? We're adding 2 square root 3 to the y value. Negative 1, sorry. And that's going to give me that coordinate. So F1 is simply going to be 2, comma, negative 1 plus 2 radical 3. F2, we're doing something similar, except we're subtracting 2 radical 3 from that y value. So that's going to give me 2, comma, negative 1 minus 2 radical 3. What's really cool about these when you're done is that these are conjugate pairs. You notice they're exactly the same, with the exception of that sign that goes in between. Okay, let's tackle one more, last one. Change the ellipse equation from general into standard form and sketch. And anytime it says to do that, we are writing all that key information down. So we'll get to practice this one more time. Group your x's. 9x squared minus 36x. Group your y's. Plus y squared minus 14y. Subtract 49, because we got to move it to the other side of the equation. Next, take out GCFs. So take out a 9. I have x squared minus 4x. There is no GCF to take out here, so I'll just rewrite that, and I still have negative 49 on the other side. Okay, complete the square. Half of 4 is 2. 2 squared is 4, but I am not really adding 4. I'm adding 9 times 4, 36. That's what I have to add over here. For the y's, let's see, half of 14 is 7. 7 squared is 49. Add 49 here, add 49 there. Now factor. This gives me 9 times x minus 2 squared plus y minus 7 squared equals 49 minus 49 is 0. That just gives me 36. Next, I divide by 36. And that will cancel. That goes in there 4 times. So here's your standard form equation. X minus 2 squared over 4 plus y minus 7 squared over 36 equals 1. Now the rest should be pretty straightforward. All right. First 3 things we get from this equation. The center, 2, 7. X pull, 2. Again, where does that come from? The square root of whatever's under the x. And in this case, that's the smaller one again, so that's b. Y pull is 6, square root of whatever's under the y. And that's going to be a, the larger one. So I always need to identify the center. Now I'm going to make my sketch. All right. So the center is 2, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. X pull is 2. So I go 2 this direction, I go 2 that direction, and plot those points. So there's that one, 1, 2, and there's that one. Again, this is the minor axis. That whole length is the minor axis because it's the smaller of the two. The Y pull is 6. All right, so I have to go down 6. Puts me right there. And up 6. 1, 2, 3, 4, 5, 6. And then, let's sketch this in. So since this is the major axis, I know it contains the vertices and the foci. So there's V1, V2. Let's write those coordinates down. V1 is going to be 2, and what's that? 13. V2 is going to be 2, 1. Okay, now to get the foci. C squared equals A squared minus B squared. Basically, I've got C squared equals 36 minus 4. That's going to be 32. So C equals square root 32. Let's see, 16 and 2, 4 radical 2, and ballpark it. That's going to be 5 point something. I'll call it 5.6. I only do that just for sketching. So I know I have to go up 5 and then just a little beyond that and then plot the point. So 1, 2, 3, 4, 5. F1 is going to be up here. And then go down 1, 2, 3, 4, 5, and a little bit more. F2 is going to be there. So I need the coordinates of F1 and F2. So I know it's a little bit challenging when they ask you to do this in simplest radical form, which they will. But you just need to kind of visualize at this point that this distance here is 4 radical 2. So whatever this y coordinate is, in this case that's 6, right? Oh no, sorry, 7 comes from the center. It's going to be 7 plus 4 radical 2. That's going to be your y coordinate. That's what you replace this with. To go that direction, I subtract 4 radical 2 from 7. So that's 7 minus 4 radical 2. We'll replace that. If you notice, they're both on the same vertical, right? With the vertices. So that means the x coordinate's got to be 2 for all 4 of those points. So that also helps you come up with the new coordinates. It's going to be 2 comma something, 2 comma something. Then you can say, oh, well, I go to my center and take that y coordinate, which is 7, and for one of them, I'm going to add 4 radical 2. 7 plus 4 radical 2. And then for the other one, I'm going to subtract 4 radical 2 from 7. So 7 minus 4 radical 2 would go there. And when you're done, remember what we said. These are conjugate pairs. 7 and 4 radical 2. One's a plus, one's a minus. Okay, so that concludes day 2. I know it's a long day of notes. I mentioned to you guys that this is going to be a challenging unit. So thanks a lot for watching. I appreciate you following along. And again, don't hesitate to reach out if you have any questions whatsoever. We'll see you in class soon.